Hello there, kids. Now, since the next topic is going to be so utterly boring, I've been trying to find ways to amuse myself and you as well. And one of the things was I was thinking about this function this algorithm I've been using for years and years, and I've always put in this web page, where I found a cute little proof in the algorithm for a random shuffle for an array, let's say, or anything, really, any collection of objects. Very simple thing. You walk through the array, going down. You can go up too, but I started the down way. So you go from the last position down to 1, position 1, where you can stop. And then all you do is you find an element between 0 and where you are, inclusive, and swap your element randomly, of course, with that random element in the list. It may not be any swap if they happen to be equal. Now, if this is a genuinely even, like an honest random selector for an integer between 0 and u, then the resulting array, the collection, will be randomized by the time you get down to the last one. Okay, well, then I tried to go to that site, and I press this, and I get this. Forbidden, no access, 404, etc., etc. Not wanting to give up, because I know it's a cute proof, and I did actually find the same algorithm in other contexts, and it actually has a name. It was eventually given a name. I think it's called the Knuth algorithm. Randomized collection. Well, it's obviously here. Random permutation. Maybe that's one I found the name of it. Yeah, Knuth shuffle. Okay, now this is goes in the other. This one goes in the other direction, but it's actually based on an earlier work that he probably wasn't aware of. There was not. It was the same basic idea, but not computationally would have been much slower. This is an in-place shuffle, as you saw. We're just swapping things. We're not creating a second list, and is very fast. It's just order the speed. They have a symbol O for the number of operations. The time taken for the thing to complete, and this is in linear time. If you have the list is 2 times as big, it takes twice as long. Whereas the other algorithm, when it's the square of the number of elements. Now, where did that go? Shuffling cards. This maybe it came out of here. Doubtful. Where was I got my history. History is what saved the day. Although it wasn't working before. The Wayback Machine wasn't working. I even downloaded Donald Knuth's book, or part of it, to try and find his proof. He's saying there's a very simple proof to this proposition. Where was that? Had to have been Wiki. Wayback computing. Oh, here, this is it. Fisher Yates. This is not the in-place thing. This is a thing that uses a pencil and a paper, and they show you how it works here. You randomly select a number from here to here, 3 let's say, scratch it out, put it in as part of your result. Then you randomly select of the remaining ones, another one, put that as the next result, and so on, right? So you can see that the idea is as this list gets smaller, you choose fewer and fewer from fewer things, and presumably it's quite an easy task to prove that that every possible permutation is equally likely. Now, I don't know if that's proven in here or whatever, but I remembered that. I mean, I've been writing. I've got this web page, all over my old source code. 1, 2, 3, 4, 5, 6 times I referenced it. And what did they do? They closed the site down, or it's forbidden now. You got to be a special member of some club. But I don't want to give up. I tried the Wayback Machine, and it wasn't working. I went to archive.org, just like this page, and it said down for maintenance. But still, eventually it seemed to kick in, and I found a date that brought up enough of it. I can't see these pictures, but if you look at and I took a few words out, but I know that I can use that LaTeX if I want to, that online tech thing. Gmail tech help. Here, code cogs. Now this is very similar to LaTeX. This should work. It's got too many brackets. Oh, come on. Nothing seems to be working today. Okay, well, I can get that'll come back eventually, I think. What is up with the internet today? Well, it might work in the mail. And I don't want a little box here. No, thank you. I don't want it there. Okay, see? That's working. A little bigger. Wait. Yeah, don't. Bigger. Small, medium. Wait, it's not gonna work. Maybe I gotta do this. Large. Maybe now it would do. Oops, won't copy that. Eight. No, same size. Anyway, it doesn't matter. It does not matter. Maybe I can change the font size. Might have an effect. Doesn't matter. Okay. That's the same thing right under that page. And now this is a product, a continued product. Oh, there's ellipsis. One ellipsis? Maybe. Not spelled right. Doesn't that look okay? That's what I want. Except I don't get my dots. It probably is a thing for dots. That's the idea. It's supposed to look like that. Everything's supposed to cancel and you end up with 1 over n. Whoops. So I can redo this whole article as an email for myself. Yeah, that doesn't look so bad. Now for the other bits of the text, well, let's see, this bit, let's say. You want a better font. What's a good font? Carre INC, of course. Or just bigger. Okay. Now these are going to be tiny and that's going to be big. I want this to be a paragraph. Paragraph? Let me make something up. Never mind, never mind. That should work. Okay, see? There's a character change. I don't know. Good idea or not? But I got my thing. I'm happy about that. Why is this not the same? Yeah. Well, I like the X and the M. I can just make this mathy and make this down. Oops. Yeah, hey. Well, maybe just no, it doesn't accept that. Oh, maybe because it's a bracket, something like that. Yeah, there's special keywords for brackets. Which you can't get from code. Oh, here. No. Well, that's inline math. It's an open brace. Well, I'm going to be working on this for a little while before we get to our boring subject. But there'll be plenty of fun things to do, while we're struggling to stay awake during it. So stay tuned and don't go away. Okay, now, boy, have we got a wing-dinger for you this time around. I'm telling you that things are gonna pick up. In just a minute, we're gonna start looking at C++ exceptions. C++ exceptions, if you recall, were the subject of Mr. Schmidt, Robert Schmidt's inaugural paper when he got hired at Microsoft. He wrote a big long paper called Deep C++, how to handle exceptions in C++. What's funny about this guy? The more I look at this paper, the more I wonder, why they hired him? What was the... I was just noticing this. I must admit a fondness for Macs, as they are the only computers I use at home. But everyone cares about technology, cares about certain technologies more than others. Given that you're reading MSDN, you're probably concerned with Microsoft technologies in particular. Yeah, and you just got hired by them. Yet all the Win32R registered trademark wisdom in the universe won't help you if your underlying language is incorrect. C and C++ can be powerful allies, but as with all things powerful, today's mismanaged ally can become tomorrow's enemy. So be careful, be careful. And eventually he goes on to talk about, well, briefly he mentions that this structured exception, whatever. Now, on to the real story. Hang on, wait, I got something here. Don't fall asleep. I'll just keep this going here. It's something interesting to look at. Now, yeah, okay, so the three words that you gotta remember. It's so cute that monkeys, gotta love them, you know? They're just like little people. Okay, try catch and throw. Sorry. Yeah. Now, this is actually, I don't think you can say this anymore. Here is a function declaration which has following it the word throw, which is supposed to indicate the types of C++ exceptions it throws. Now, what does all that mean? Well, for one thing, it will not prevent your dog from playing on your piano. No siree, but it might help you keep your job or at least pass the job interview, because you probably won't use it ever again. Let's see now. Well, we can go to my example. I made up two examples here. The basics and the slightly less. We're going to have to make some more room here. Sorry, kids. Shrink you down a little bit. Pooch. I have two unit tests lined up. Unit test 2 and 3. Now let's make 2 be our current one. As if, these ones take Boolean, if I recall. Yeah. Because there are usually two cases to do these C++, well, these exceptions, whether the exception is going to get thrown or not, or something else. I want to at least pass a Boolean, fail, true or false. I'm going to say false for fail, and compile this. While that's compiling, we can watch this little kitty cat. I used to have a cat. Her name was Fluffy. Well, she wasn't my cat. So I can't really say I had a cat. But it was a little bit like that, I guess. And this is a lot more fur. It's a little bit more animated than my cat was. Yep. Hang on, I'm sorry to interrupt the entertainment, but this is taking forever to build. Sorry about that. I know that you missed a few, you didn't miss that much, really. And there's a lot more coming, trust me. Alright, now, Carre test 1. Well, the best way to look at it is to just step into it and have a look and see what it does. Okay, now I took this sample from the helpful hint file, and oh my god, Or a kitty cat. Now, my sister has a cat just like that one. Anyway, yeah, so here was their example. Car star buff, allocate new buff. Now that's why I put in this fail, because I can't think of a way to make malloc fail unless I put 8 gigs or something. It's not going to fail. But I can simulate a failure by just passing in a fail. But I haven't. I set oops. This is false. And now the way it works is in C++. If you want to get out of a bind and you're in a situation that you put yourself into where there's absolutely no way out, and the world's coming to an end, then what you can do is you can sort of pass the buck by calling this throw here. So memory allocation failure is that now that's a string. Now in the helpful hint file, there was a bug here. The const modifier was not included, and in fact I found that in most of their examples, and that would be an error because if this were declared as in the example, then we would be allowed to modify the contents of stir, and that would cause another kind of exception, which can't be handled with C++ exception handling. We would be in really big trouble. So it's best to put that const in there. Now, if buff equals 0, we're going to throw. Hey, state letterman. What's he doing on my pets? Oh yeah, most of them were him, and eventually I changed my search to minus David Letterman. Okay, now buff is not null, so now the idea is that just like in baseball, if you throw a ball, then somebody has to catch it. And here we haven't thrown anything, so nobody has to catch anything, and this code won't get executed. Pretty good, huh? Okay. That's test 1. Well, that's test 1 with false. Now let's try with true. So we're going to have a memory allocation failure. Simulated, of course. Pause again. Okay, you didn't miss much here. Alright, now here, try and pay attention to the code. Now this time, through simulation, since B fail is true, our buff is going to be null, and then now it's like we're throwing our baseball, and now for anything that we throw, there has to be a corresponding some person to catch it, and that ends up with us in here, which we print out the exception here. Stir is memory allocation failure. That's the string that was passed to the catch handler. Okay. Now that's pretty good. It's one way of quickly getting from one place to another. Kind of like GoTo. If you like GoTo, then you'll like this. Okay. Now here's a question. This here matched with this. What if it didn't match? What if this What if I just put a number here, like 6? What's going to happen in that case? Try and take a guess. Actually, I think I have this example below as well. I'm going to pause again. It's a lot of work for the processor. I don't even know if it's recording my voice. But I'm going to run up to here again. And you're going to see that something happens here. What we got here is an unhandled exception. It's a C++ integer exception at 12fe6c. Is that really where we are? Okay, I guess that looked more like a stack number. So if we don't have a catch handler, you think of this as like, or a catcher or whatever. It's like a baseball team. You know, one guy catches the outfielders catch the long batted balls, and infielders catch different things. You got to have for the corresponding type of throw, you have to have a matching catch. Now, this said unhandled. It's possible, say, to just add a catch for that type. Now, this is an integer type according to the error code. So we can say int error, and we can do integer exception and print out what the integer was, and that should work. Okay, let's try it again. We'll have to pause again. There we go. Okay, all ready to go here. Now this time, I'm going to run up to the same spot. Buff will be null. And we're going to throw a 6, and voila, it put us in the right spot. Okay. Well, what if, well, I'll get to it. Now, we knew already that thing threw an integer, right? But there's no way to tell with certainty every possible thing this block of code might throw. It might not even be our block of code. So, there's a special way to indicate a catcher that'll catch anything left over, all the leftover junk that got thrown. All right. Okay. Let's see now. Now let's go on to test number 2. Now here this shows throwing simple data types like strings and well, the string's gone. Put it back. Alright, we'll make this random. Oh, I discovered a new random function. I'm going to tell you all about it. Odd or even. I didn't know until today there's another brand. I don't know if this is even allowed. It's like returning 2 types. But you never know. It's C++ exceptions. It's very flexible. There's a very good chance that that'll compile. the type of exception is sort of like parameter. They didn't like it. It has to be one line, I guess, has to be. So you could say, you could use an if. It should do that. So here we have this should be in brackets. We got if and then else, and we don't dangle our ifs. We want this else to belong to this if and not this if, and we want to be sure of that. You'll notice, by the way, that there's a warning here, and we'll get to that later. Okay. Not the unreachable code, but this thing. Although I haven't. Oh, maybe I've got one down here. I did. That's the special thing I was going to tell you about. It's coming up in the next test. But we can take a break from it. We can take a break from it and stop it. I can show you my new wallpaper. Get this all set up to make this as interesting as possible. And then another sexy smoker one. This time with a famous actress in it. I'll probably get sued for it. What was her name? I think she's Australian. Her name is Emily Browning. She's an actress. And I got her in a sexy position. Oh, here she is. Here. Come on up here. And she's so she would be like what you would call a woman on the move. She's a busy person, has no time on her hands, lots of money, but busy acting career. And these other pictures are people in the sort of opposite. I've seen her before. Opposite side of life. Plenty of time with her hands, no money, no busy career, lazing around with nothing to do. So, well, you can let your imagination wander, and just think about what's someone who has very little time but lots of money on their hands, what they might be doing is smoking a cigarette by the poolside and on the telephone. Could be talking to her agent. But that wasn't the idea of trying to convey. I think she might be trying to call up a friend. Alright, back to work. Back to work. Going on to Kerr test 3. Now, this is a slightly less basic example of C++ exception handling. Oh, now look what happened to my... Let's get these guys going again. You see how much fun it is doing a C++ except... Oh, do I want false or true? Start with false again. I'm going to have to pause this. Oh, we're up to 22 minutes. We're doing pretty good. We're almost through it. Almost through it. Alright. Now, in this case, actually, this is what I've done. Is I've got 3 types of things that can be thrown, but from within this try here. Okay. Now, I actually stole part of this example from the help, and I've put funcs. In order to demonstrate one of the amazing features of the C++ exception handling mechanism. And I think you can probably guess what that feature is. Whoops. So here we are in that function. Fail is false. Okay. And now we're going to call something called myFunc. Alright. Okay, now myFunc is creating something called a D. And you can see that it's constructor.enter. Now we're about to throw not like a string or a number, but an object, like a C++ class called ctest here, and I've got put func here and so on. And we're interpreting this class as a more descriptive type of exception that contains within it a function that can tell you more information about what happened, what the reason is, for instance. Now, this is not, there's nothing unusual about this. This is normal in C++. Now I'm going to throw this. Now the question is, where is it going to go? Well, it turned out that we had a catch handler that catches just that exact type of structure. And E here would be the one that was created. Here, it was created, the ctest was created, and a ctest has been destroyed. Okay, but this here catches a full object, so I imagine you must copy it or something. E would have been destroyed, according to this. Well, it's going to print out the right thing, alright, but if that were a member, I don't think it would have worked. Now, don't tell me this is another bug in the here examples. Let's see. Let's make that string a member, TS string. Now that thing destroys itself. Then reason is not going to be valid. I think that finishes. I hope you enjoyed the stupid pet show and the sexy actress with sexy thoughts on a sexy afternoon. Now let's see what happens here. It's about to throw, and it came up to here. Aha! Now look at that. It hasn't destroyed itself. It knows that it's not allowed to destroy itself because it's got member data that needs to survive at least this part, and it still works. How about that? Now that C-test thing should destroy itself. I hope. There it goes twice. Now why exactly? Why would that 2 destroy? Oh, because there's a copy. Now where's the copy? Oh, we're not. The copy constructor was not printed out because that was automatically generated. But if we had explicitly made a copy constructor, we would have seen 2 constructs to correspond with these 2 destructs. And we're back where we were. Okay, so there's one difference. Objects destroy themselves correctly, usually. We have to take special care in the case where an object might throw an exception during construction. If it's constructing itself and it decides to throw an exception, there's a way to handle that, and I'm not going to explain because I don't think that anyone needs to know it. You shouldn't be writing constructors that throw exceptions. Okay, B failed. Now I'm using some randomness. Okay, now we're throwing out this type of object we've seen before. And I'm catching a copy of that object. So again, we should, well, although I'm not marking them, we should see the destructor TS string get called twice. We might have missed one already. Probably did. There's one. There's another one. Oh, okay. Uh-oh. Man. I don't know where we are. I'll just keep running. Caught exception, some random string. Well, we're in the destructor. Right. And these also give nice printout too. First chance. There's a meaning for that. First chance, second chance. Sometimes a handler for a particular exception might pass the buck further, and I think then they call that a second chance. Another handler gets a chance to handle. Now that's pretty much almost all there is to C++ exception handling. Well, let me just give you the name. Now this is totally my personal feeling about it. You may feel completely differently, but I did a search, entire solution for the word cache to see how often I use this mechanism. Okay, now here's one in my thread prop stub, where it's the standard exception is just type that's supplied by the standard header files, and it has a descriptive thing. So there's one case where I use it, and it says somebody threw this. Okay. This here is in the unit test that we're doing. Unit test, unit test, unit test, unit test, and so that's it. There's a one. I use it once, and I've never needed it other than that. I remember when at this point I'm rambling. You can ignore the rest. But when I was first working, after working for that office company, a friend of mine and myself started our own little company, and we used a lot of MFC, or he had anyway in his code a lot of use of MFC stuff. And one thing MFC comes with is something called they have a file class called C file. And I found it in the help and asked my friend Steve, well, why are you using, F open and stuff? And they've got a class for it, it's got all kinds of members and stuff. And I don't remember exactly where he showed me. Was it one of these things here. I can't remember where it was. It's one of the constructors can take a file name and so therefore you have to be very careful with this class and make sure to surround everything with tries and catch. And the example was so basic, like at such a basic level. It's just declaring the thing. You had to have I wish this thing had a history. Let's see. It might be in this topic. Okay, well, here you go. Try, open, catch. He didn't want to have his code littered with try and catch everywhere. And that's understandable. Especially when you're talking about just create, just declaring something. Well, I don't think that one opened, didn't it? It's not there. That opened. It just becomes quite a bit of a mess. And the thing is, any of these functions that you call can throw an exception, and you don't know what it's going to throw. It doesn't tell you. Well, it might tell you if you look everything up. But then where are you gonna catch all these errors? Like right underneath, or at some higher level? What's the advantage of this mechanism? I wish I could find it. Exceptions out. Maybe I've written favorites. Yeah. When it tells you when you're supposed to use them, this type of exception can be thrown, obviously. They're not only error conditions, they can be just normal conditions, like you failed to open a file. Well, I can't find it. In any case, sometimes you have to have a try, and sometimes you don't have to. We call one of these ones safe. And the other thing is that, oh, here it is. Here. How I got there, I don't know. One of the live papers. Okay, here's someone declares a pointer to a file. Okay. Now, constructing a C file with this override may throw an exception and won't throw any other exceptions. This type of exception is file exception. Calling C string format may throw a memory exception. Well, it might, but not bloody likely. So we have to have two catch blocks for the two types of exceptions. Other exceptions, others will, be caught by some surrounding block. So now, if a file exception is caught, we've got to print this out. Now, all this is doing is making a new object, right? And then formatting a string. Forgetting about the memory exception. If exception occurs in the C file constructor, the language will see the memory, but will not complete the assignment here won't complete. So the memory got cleaned up automatically before this occurred, and you have to be sure to test if the thing's null, whether there were exceptions or not, before closing. It's just a big hassle. I think I agree with him. It's much easier to just say, F open. Get a pointer to a file, read the data from the file, or make your own. I have my own class. It doesn't throw exceptions. It does have a constructor that takes a file name, mine, not in here, but in my other code. But it doesn't throw any exceptions if that fails. You test, there's a function called succeeded or something. Right here, it's a standard usage of file, path, and mode. If not file success, do something, right? Fail to open file. But that gives you just as much flexibility without all the worries. And like, do I need to have a try here? I'm about to close a file. Do I need a try block? Where should I catch it? Maybe some other part of the code is supposed to catch that. The non-linearity of all these throws and catches makes code that relies on that as a method of program execution flow control essentially like returning to go to, right? So it's like programming in C. But it's worse than that because your go-tos can go across functions. It can span the entire program from one end to the other. Everything gets all nicely cleaned up. And it becomes very difficult to understand how the execution flow is moving along. What's going to happen next? I'm on this line, right? Now this doesn't have a try thing. Usually you're supposed to put them in. Now they have their thing written in terms of these macros. You notice those were capital letters, those macros. See, exception-derived objects may be thrown by the framework or by your application. And so you got to go through all this stuff. But this doesn't look so bad, right? Some code. But when it's everywhere, when every function looks like this, try and catch, and then you got tries and catches outside, you start to wonder, like, what happens after this line? Do I go to this line, or am I over here, or am I in another function, right? So stay away from this as a method of flow control. Don't use exceptions for things like simple error handling. Okay, failed to allocate memory, just terminate the program. Fine. File exception, that could mean like it failed to open a file. That's not an exceptional condition in a computer program, right? All other types, okay, well what does that cover? What is all other types? C exception. Invalid argument, not supported. File exception. OLE, internet exception. Okay, the internet's not connected, so we're gonna, that's an exception. That's a crash. We're gonna invoke a crash because the internet's not connected, right? Oh, we can't find a resource, so therefore crash. But it's not a crash, it's just an error condition. Well, okay. Error conditions, errors can be handled in the immediate vicinity where the error occurred. And that's where they should be handled, not far away in some other land. That's my take. And then now the next video, we're going to move on to the interesting exception topic, where the exception is a real exception, not something that you throw and make up, but something that happens and is generated by the hardware when the hardware can't recover from a fatal condition. And I want to do what I said before, and also show you some of the examples that I've found in the past couple of days searching around. Okay, hope you enjoyed that. Another look at Browning here. What's her name again? Where is she again? Emily Browning. Australian, I think. I like her friend. Okay, see you.